All right, if you're following along, this is AP Environmental Science. This is section 9.7, ocean acidification. So we're going to start talking about ocean acidification. What is it? What are the problems? Why should we care? Let's do it. CO2 enters the water. It dissolves into water and forms H2CO3, which is carbonic acid. The fun chemical equation right down here for you. CO2 plus H2O, right? Ignore this part. Ignore that part just for a moment. CO2 plus H2O form H2CO3. That's carbonic acid. Carbonic acid dissolves the shells and skeletons of marine organisms like crustaceans, mollusks, and corals. So this is a great graphic for you to show you ocean acidification. How is it going to change ocean chemistry, which affects the marine life? So CO2 is absorbed by the atmosphere, right? When there's CO2 in the water, bonding with the carbonate ion inside of the shells, right? It creates two bicarbonate ions, but it hurts the shell's ability for protection. So the shells, these different skeletons of the crustaceans, the mollusks, the coral, are being degraded. They don't have the carbonate that they need to build their strong skeleton. All right, so here's the process, right? Carbon dioxide from the atmosphere is absorbed by the ocean. So then dissolved carbon dioxide can bond with the water to form carbonic acid. Okay, so carbon dioxide reacts with seawater to form carbonic acid. It lowers the pH of the ocean. Hydrogen ions released by the carbonic acid will bind to carbonate. This is what happens when acids mix with bases, right? So hydrogen ions will mix with the carbonate to form bicarbonate, HCO3, and the carbonate concentrations are decreased, which makes it difficult for shell-forming species to make calcium carbonate because they don't have the carbonate to make their shells with. And this is the kind of loop from atmospheric CO2 down to the effect of ocean acidification. So some more information about ocean acidification. This is a great little interactive for you. You can see it's not an interactive, it's just a beautiful picture. So the ocean absorbs CO2 from the atmosphere. The CO2 breaks down to form carbonic acid. The free hydrogen ions then bond with the available carbonate ions to form bicarbonate, which reduces the concentration of carbonate. The carbonate ions are required for marine life to build and maintain calcium-based structures such as shells and coral. An acidic ocean ecosystem has a lower concentration of carbonate ions. Ultimately, an unhealthy marine ecosystem has ocean acidification in it. This is still kind of in 9.6, ocean warming. But let's look at sea level rise. So this is based on satellite data from 1993 to present, and what we're seeing is that the rate of change of sea level rise is 3.41 millimeters per year, and that doesn't sound too bad. That doesn't sound like much, right? 3 millimeters a year? That's nothing. Well, it's been 9 inches. That's 9 inches since 1990 here, 1993. 9 inches in what, 30 years? That's not too bad. Well, by 2100, that could be 7 to 23 inches more from that. So that's a total of almost, 32 inches, right? It's not too bad. The total volume of water is going to increase as the land ice melts. Think about, sea ice melting is like ice in your water, right? You put ice in your water, it melts. Your water doesn't overflow. But if you add more ice to your water and then it melts, it's going to overflow. The water also will expand as it gets warmer. That's just thermal expansion. So that's also causing sea level rise. And some of the effects that are going to come from this: flooding of coastal nations and towns, saltwater intrusion into aquifers, which means we have less fresh water to drink. It's also going to cause increased erosion. Not good. Bad things. And this is what's really important. 100 million people live within 3 feet of sea level, right? They live where the ground that they're standing on is only 3 feet above sea level or closer. That's why these numbers are a little more scary. Now, increased sea level also increases sea surges. So this is an example here of storm surge and high tides in local areas. So the idea here is that a 2010 high tide storm surge, this is where they could, you have a building here. That's not too bad, right? You can maintain this. The problem is by 2050, anybody who lives really close is gone. Okay? The 2010 floodplain goes to here. The 2050 floodplain is here. And all of a sudden, you get close enough to a large urban area, the storm surge creates massive, massive problems. It's a great case study here on the Maldives that I want us to watch, but I'm just going to throw this video into the Ed puzzle. So make sure you watch that video. If I forget, there's the link. Just type that in and watch it. But we're gonna move on. It also has effects on organisms, of course. The ranges have shifted towards both poles. So this is looking at the average distance moved north in miles. And we can see that over time, both poles, so far away and far down, are shifting, but overall they're going farther and farther. As CO2 increases, the range of the Asian tiger mosquito is going to increase. So some more downsides, right, of increased CO2. Plants and flower. You can't even read that. So the plants are actually flowering earlier, which causes birds to migrate earlier, which means that insects are going to emerge earlier. So climate change has actually moved the peak abundance of cranefly larvae earlier. So eggs were laid. It used to be perfect because the cranefly larvae would be eaten by the chicks, right? But climate change has caused the larvae to be earlier, which means that the cranefly is not there to eat it, which means now we have a higher abundance of the cranefly. Coral bleaching is also another problem where you have the temperature tolerance of a coral being very small. They can tolerate very, very little in change of temperature. Coral bleaching comes from increased temperatures in the water. So here's some information about coral bleaching and what causes it. A lot of people think coral bleaching is related to ocean acidification. It is not. So make sure you know that. Healthy coral depend on each other. Coral and algae depend on each other. When you have stressed coral, the algae will actually leave the coral. So now it's left bleach and vulnerable. So healthy coral has algae and an interdependent relationship. What are some of those causes? Increased ocean temperatures, runoff and pollution, and overexposure to sunlight. So you need that algae to be there on the coral to protect the coral. So here is the Great Barrier Reef, I believe, area. We're looking at Australia. And we can see some of the bleaching that is occurring in the northern sector. 522 reefs were surveyed. 81% of them were severely bleached. Only less than 1% were not bleached. And as you move farther south, closer, which would be colder temperatures, right? That's where you're going to find better situations. But that is not a good thing. We don't want any of these to be bleached. We also then start getting fragmentation, right? So fragmentation can actually prevent migration. So this is looking at climate connectivity. Succeed via neighborhood natural areas, only succeed with corridors, and never succeed. And these are, migration of animals. If they can't migrate, then they're not going to do well. So we can see in the west where there is less urbanization, we have a lot more open area here. There's more success. There's less success in land in the east. Some of the future effects of global climate change, of course, heat waves. We're going to see an increased energy demand. There's going to be a higher risk of death to poor and elderly, and there's going to be damage to crops, which is going to increase, which is also going to cause an increased irrigation needs, less food for people. Number of extremely hot seasons per decade. You can see here from 2010 to 2019, you see orange and yellow. By 2030 to 2039, we're looking at many, many, many more events per decade. Purple and red. Not good. It's not going to be good. We're looking at some Mad Max action going on. We're also going to get cold spells. I'm getting close to that 10-minute mark. I'm going to end the video.